All right. Multiplying matrices. Okay. So we're just going to talk about a generic A and B matrices. I know you have some matrices over on the left side of your paper. For this particular explanation, just think generic A and B, not the ones that you see over on the left. Okay, we'll talk about those in a minute. So two matrices, A and B, can be multiplied if and only if the number of columns in matrix A, we'll just call it A, equals the number of rows in matrix B. Okay, so there's your rule. So with adding and subtracting, the dimensions had to be the same. Same number of rows, same number of columns, then we can add and subtract. But for multiplication, the number of columns in the first matrix that we're multiplying have to be equal to the number of rows in the second one. All right, so I'm going to show you a little notation that's going to help you out with this, but and I'll do that in this explanation here. So if matrix A has dimensions m by n, and above the m, let's put a little in parentheses r so that we know that the dimension m is rows and n is columns. So if matrix A is m by n and matrix B has dimensions n by p, again, this is going to be rows and columns, then we can multiply those two because you'll notice that the columns in matrix A, which is represented by is the same as the rows in matrix B, which is also represented by same. So when the columns of A match the rows of B, we can multiply, and the resulting dimensions of the product are going to be m times p. Okay, so watch this. This is the little notation that I'm going to give you. Same thing I just said. Look, here's rows by columns, product, dimensions. So what we're going to do is we're going to write out the dimensions of our matrices, and then we're going to draw a little box around the columns of A and the rows of B. And if those two numbers are the same, we're going to put a check mark. And when we put that check mark, that means we can multiply them, and you'll see that the remaining rows and columns become the dimensions of the answer. Get it? Okay, so let's talk about these matrices over here. So we're going to start first by, just out front here, I want you to write the dimensions of each one of those matrices. Go ahead and do that now. So you should have put, for A, a 4 by 3, 4 rows by 3 columns. For B, a 1 by 5, 1 row, 5 columns. For C, a 2 by 4. For D, a 3 by 1. And for E, a 5 by 2. Everybody good? Okay. All right, let's talk about, can we multiply AD? Can we get a result of AD? So here's what I want you to show me for work when you write this out. You're going to start with A and go 4 by 3. And then you're going to start with the dimensions for D, and you're going to go 3 by 1. And then you're going to go box around columns of A and rows of B. You're going to verify that those two numbers are in fact the same. When they are, you're going to put a check mark. And the question is, can you multiply them? The answer is yes. And I want to know what the resulting dimensions are. So our answer is going to be a what? A 4 by 1. Now, when it comes to typing that into formative, right, again, I'm going to give you more spaces than you need, and you'll be filling in the empty spots with NAs. So it's really important that you know what the dimensions are of your answer. How about BE? Let's talk about BE. Can we multiply BE? Well, okay, so B is a 1 by 5, right? Yeah. All right, and then E is a what? 5 by 2. Okay, so let's draw our verification box. Check. So what is the resulting dimension since we can multiply this? This is going to be a 1 by 2. Nice. How about AC? What's the dimensions for A again? 4 by 3, right? What are the dimensions for C? 2 by 4. Let's check our verification. Does that work? Just draw a line through it like that. And then you can say, no, can't multiply. And for your formative, that means you'll fill in all of your answer boxes with an NA. Yeah. But it should be pretty easy to do. Okay, we haven't gotten to how to do it yet. We're getting there. But let's just figure out if we can do it first, Sophia. Good, I like your forward thinking, but we're not quite there yet. Okay, so here's what I'd like you to do. I want you to finish 4, 5, 6, 7, and 8 the way that we did these. Go ahead and tell me whether you can or cannot multiply. And if so, what is the resulting dimensions? Ready to go. Here is what you should have come up with for the remaining. How did you do? Good? All right, so the first thing that you're going to do with all of your problems that you have is to determine, can you multiply those matrices, and what, if you can, what are the dimensions of your answer matrix, okay? So that's the first thing that you're going to do, all right? Now, when we can do it, we need to know how to do it. So let's talk about that. All right, now listen, I want you to think of this empty space down here sort of as kind of being broken into two sections. We're going to take some notes up top here, and then we're going to do an example down here. All right, so just kind of space your notes accordingly. Okay. So let's give ourselves a little asterisk or a bullet point. So here's how we multiply matrices. All right, focus right up here. Especially if your name is Arjun. There we go. I tried, man. I tried not to do it. I tried. You were listening. Okay. All right, here we go. So we're going to multiply rows by columns when we do this process. So for example, it might look something like this. Row 1 times column 1, etc. So once we know that we can multiply, we're going to go row 1 times column 1, and then row 2 times column 2, and then row 3 times column 3, like that. So we're going to multiply matching row numbers by matching column numbers. Okay? Now, this is where it gets a little tricky. The answer elements, right? Those are the individual things inside the matrix, right? Okay, matrix. The answer elements are going to be made up of the sum of the products of the corresponding. I know, right? Listen. I tried really hard to figure out a way to say this as like lean as possible. Of the corresponding elements in the row times column process that we're going to be doing. So the answer elements are the sum of the products of the corresponding elements in the row times column process that we're going to be going through here. It's going to make a lot more sense when you see it written out in an example. So let's do that. Let's say right here, if matrix A, and then we're going to just write out a 2 by 2. We're going to call these elements A, B, C, and D. Okay, so if matrix A is A, B, C, D like this, with these elements, and matrix B is going to be E, F, G, H, like that. Then the first question is can we multiply these two matrices? Yeah, right, because we got a 2 by 2 and we got a 2 by 2, right? And so we can check our columns versus rows, good to go, and that's going to leave us with an answer matrix of a 2 by 2. Everybody good with that?
Yeah.
Okay. So then AB, right, where we slam them together, that means multiplication. So that's the product of A and B, is going to be equal to a 2 by 2. Now let's do this. We're going to make kind of a nice big matrix here. And what I want you to do is I want you to do a circle here, and a circle here, and a circle here, and a circle here. That's our 2 by 2. Okay? Now, what's going to go in here is going to be the result of, I'm going to put N here. This is going to be the result of row 1 times column 1. So N11, which is the element number, is going to come from row 1 times column 1. So then element 1, 2 is going to come from row 1 times column 2. And then element 1, 3, or element, sorry, I did that backwards. It should be 2, 1. Element 2, 1 is going to come from row 2 times column 1. And then element 2, 2 is going to come from row 2 times column 2. Are you with me?
Yes.
Okay, so it's going to look like this, right? Let's talk about N11. It's going to be row 1 times column 1, and we're going to multiply the corresponding elements together. So in other words, if this is row 1, 1, then this is column 1, 1. We're going to multiply A and E together, and then we're going to multiply B with G. Second position, second position. So first position, second position in the row, first position, second position in the column. You see how it's working? So this first one is going to be made up of AE plus BG. It's the sum of the products of the corresponding elements in the row times column process. Do you see how the definition plays out now? So we have to multiply first position by first position, and then second position by second position, row 1 times column 1. That's what ends up as element 1, 1. Why don't you take a shot at what you think is going to go here? Give it a try. If you get it wrong, you erase it. Big deal. Go give it a try. Let's see if you can get it. It's going to be row 1 times column 2. And if you did it right, you should have gotten AF plus BH. How'd you do?
Yes!
Did you get it? Give me a thumbs up if you got it right. Let me see you around the room. Okay, not as many as I'd hoped, but that's all right. Good. All right, let's do it next time. Yeah, let's do it next time. That's a good one. How about N21? This is row 2 times column 1. Row 2 times column 1. Let's see if you can do it. Row 2 times column 1. Row 2 times column 1 should be CE plus DG. CE, got it? You got it? CE plus DG. Okay, do the last one. Row 2 times column 2. Row 2 times column 2. Okay, you should have put CF plus DH. How'd you do? CF plus DH. Okay, so you see what we're doing? We're multiplying rows times columns. It's easy to remember what rows and what columns because it matches the element number in the answer matrix. Okay? And then it's corresponding elements. First position with first position. So if it's row 1, column 1, it's 1 and 1, and then 2 and 2. And if it goes 3 and 3, or 4 and 4, however it works, depending on your problem. Okay? All right, we got about 6 minutes, and I want to do at least one of these with you, and it's on formative. So grab out your iPads, go to the formative main page, and let's start multiplying matrices. Okay, you should be looking at lesson 15 homework. Okay, so the first set of questions is going to be in the show your work section. So let's go to the show your work section. Okay, so I'm going to minimize this so I have a little room to work with over here. All right, so here's how I want you to write out your work. So let's start with, can we multiply number 9? And so we have a 2 by 2 and we have a 2 by 2. So then you're going to draw your verification box for me. You're going to give me a yes and then a resulting answer matrix. I want you to practice writing it like that. Okay? Now, what you're going to do is you're going to make a nice big 2 by 2 matrix to work with here in your work section. And I would definitely recommend doing the circles for right now just to make sure you keep things organized. And what I want to see from you here is one level of work showing me the sums that you do. So for example, let's take 1, 1. That's row 1 times column 1. So what am I multiplying here? What numbers am I multiplying? Negative 4 times 6 and? Okay, so negative 4 times 6 is going to be negative 24. And then negative 9 times negative 5 is positive 45. So I'm going to write plus 45. Be on the lookout, because if it's a negative number, the second one or the third one, whatever, then you want to write minus that number, right? Okay, so then why don't you do row 1, column 2. So let's fill in this oval here, row 1, column 2. So this is going to be negative 4 times negative 1 and negative 9 times positive 4. So you should have wrote 4 minus 36. See what I did? It's coming from negative 4 times negative 1. And then negative 9 times positive 4, because it's row 1 times column 2. Okay, see if you can write out the sums for the last 2 problems here. Okay, see if you can write out the sums for the last 2 problems here. Go ahead. Okay, now, I don't really care if you write your answer down here or if you just do the math at this point and then type it into formative. It's your choice. This is what I need to see in the work section. I need to see at least one level of work where you're showing me the sums. But if you wanted to write it down, we know this is going to be a 2 by 2 matrix, right? So then I do negative 24 plus 45. What's negative 24 plus 45? 21. Positive 4 minus 36? Negative 32. 18 plus 10? 28. And then negative 3 minus 8? Negative 11. That's the 2 by 2 you type into formative right here for question 9. So it's going to take up these 4 boxes, and then you got to fill in everything else with NAs. Okay? Now listen. Sign errors, sign errors, sign errors. Be very, very careful with your signs. Speedsters, slow down. It kills in real life and in math. Slow down. Watch your signs. Write your work out carefully. Use a calculator. Don't make computational mistakes. Good luck. The rest of these are your homework.